The universe is vast, beautiful, and teeming with energy. From the radiant heat of stars to the swirling dance of galaxies, it feels eternal, boundless, and full of life. But what if I told you that this energy, the very lifeblood of the cosmos, will one day run out? This isn't science fiction, it's a scientific prediction. The universe is slowly but surely heading toward a state of absolute stillness, a point in the far future known as the heat death, or the great cosmic freeze. What does it mean for the universe to run out of energy? How do we know this will happen? And what will the cosmos look like when everything we know and love ceases to exist? To answer these questions, we need to journey through the laws of physics, the life cycles of stars, and the chilling predictions of the universe's ultimate fate. To understand the great cosmic freeze, we first need to understand how energy works in the universe. At its most fundamental level, the universe is governed by thermodynamics, the study of heat, energy, and the movement of particles. The second law of thermodynamics states that in a closed system, entropy, the measure of disorder, always increases over time. In simpler terms, this means that energy becomes less usable as it spreads out. A hot object transfers its heat to a cooler one until both reach the same temperature. Once this equilibrium is achieved, no further work can be done, because there's no temperature difference to drive energy flow. Now, think of the universe as a closed system. All the stars, galaxies, and black holes are burning through their energy reserves, radiating heat into the cold void of space. Over time, this energy becomes more and more diffuse until there's no usable energy left to sustain motion, light, or life. The story of the great cosmic freeze begins with the expansion of the universe. Ever since the Big Bang, about 13.8 billion years ago, the universe has been expanding. Galaxies are moving away from each other, carried by the stretching of space itself. In the early 20th century, astronomer Edwin Hubble discovered that this expansion is not slowing down, as scientists once thought. In fact, it's accelerating, driven by a mysterious force called dark energy. This acceleration means that galaxies are moving farther apart at an ever-increasing rate, making the universe larger, colder, and emptier over time. As space expands, the energy in the universe is spread thinner and thinner. The temperature of the cosmic microwave background, the faint afterglow of the Big Bang, has already cooled to just 2.7 Kelvin, barely above absolute zero. In the distant future, as the universe continues to expand, this temperature will drop even further, plunging the cosmos into an unimaginable cold. Stars are the engines of the universe, converting hydrogen into helium through nuclear fusion and radiating light and heat. But stars don't last forever. Even the most massive stars burn through their fuel in a few million years, while smaller stars like our Sun will shine for billions. Eventually, every star will run out of fuel and die. The most massive stars will explode as supernovae, leaving behind neutron stars or black holes. Medium-sized stars like the Sun will expand into red giants before shedding their outer layers and becoming white dwarfs, small, dense remnants that gradually cool and fade over trillions of years. In the far future, no new stars will form. The universe's reservoirs of hydrogen, the primary fuel for star formation, will be depleted. With no new stars to replenish the cosmic light, the galaxies will grow dark, filled with the faint glow of dying remnants. As stars fade away, black holes will become the dominant structures in the universe. These enigmatic objects, formed from the collapse of massive stars, are regions of space where gravity is so strong that nothing, not even light, can escape. Black holes, however, are not eternal. They slowly lose mass through a process called Hawking radiation, named after physicist Stephen Hawking. Over an unimaginable timescale, trillions upon trillions of years, black holes will evaporate, releasing their energy into the void. When the last black hole vanishes, the universe will enter its final stage, the Dark Era. The Dark Era will be a time of absolute stillness. All stars will have burned out, all black holes will have evaporated, and all matter will have decayed into subatomic particles. The universe will be filled with a thin soup of photons, neutrinos, and other particles spread so far apart that meaningful interactions will become almost impossible. At this point, the universe will reach maximum entropy, a state where all energy is evenly distributed and no work can be done. This is the heat death of the universe, the great cosmic freeze. It will be a cosmos of infinite cold and silence, where time itself loses meaning because nothing changes. The prediction of the great cosmic freeze is based on well-established scientific principles, including thermodynamics, general relativity, and quantum mechanics. Observations of the universe's expansion, the distribution of galaxies, and the behavior of dark energy all support the idea that the cosmos is heading toward an era of increasing entropy. While alternative theories exist, such as the Big Crunch or the Big Rip, the heat death is currently the most widely accepted scenario for the universe's end. The Great Cosmic Freeze is an unsettling concept. It challenges us to think about the ultimate fate of everything we know and love, but it also offers a profound perspective on the fragility and beauty of existence. Life as we know it is possible only because of the energy gradients created by stars, planets, and the flow of heat. These gradients drive evolution, technology, and the very act of living. The knowledge that these gradients will one day disappear underscores the importance of appreciating the fleeting nature of our universe. While the Great Cosmic Freeze may seem like the end, it's also a reminder of how far we've come as a species. From ancient stargazers to modern physicists, humanity has worked tirelessly to understand the cosmos. Our discoveries about the universe's beginnings, its present, and its future are a testament to our curiosity and resilience. The universe's ultimate fate may be a frozen void, but our legacy as intelligent beings who dared to ask the big questions will endure for as long as the cosmos allows. The universe is a story of energy, motion, and transformation. It began in a fiery explosion, flourished with the birth of stars and galaxies, and will eventually fade into stillness. But in that story, there is beauty, wonder, and a reminder of our connection to the cosmos. As we continue to explore the universe, let us cherish the warmth and light we have now, knowing that it is part of an extraordinary journey. The Great Cosmic Freeze may be inevitable, but so too is our capacity to understand, to create, and to find meaning in the grand sweep of the cosmos. Stay curious, stay inspired, and keep exploring the mysteries of the universe. The story isn't over yet, and every discovery brings us closer to understanding our place in the infinite expanse of time and space.